Hello, this is Ben with Math Moments, and I hope you're doing well today. Today's topic, we're going to talk about Pythagorean identities. These are the trigonometric Pythagorean identities using the unit circle, which we know is x squared plus y squared equals 1. Since we have a radius of 1 for our unit circle. And unit means 1 when you're talking about unit in mathematics. And so the way we're going to identify these, or actually derive these Pythagorean identities, is use this right triangle here. So we'll say this is angle theta. And we know that the hypotenuse, or the radius in this case, is 1. And so we know this side is going to be x. The horizontal side and the vertical side is going to be y. So to get the x and y in terms of theta, we're just going to use the trig identities. We know that cosine of theta, that's going to equal the adjacent, which is x, over hypotenuse, which is 1. So that'll be x over 1. So that just means that x is cosine theta. And then likewise, we do the same thing for y. We're going to say that sine of y, or sorry, sine of theta equals y over 1. Getting my words mixed up here. So that's just going to imply that y equals sine theta. Now, if we substitute the x and for cosine theta, and then we also have the y as sine theta, we put that one there, we see that we get the first Pythagorean trig identity. So that's going to be cosine squared theta plus sine squared theta, and that equals 1. So there is our first Pythagorean identity. Now there are two more identities we can derive from cosine squared plus sine squared equals 1. And what we'll do to derive that is we'll take this equation, cosine squared plus sine squared, and the first thing we'll do is we'll divide both sides, or each term, in the equation by cosine squared theta. So cosine squared theta divided by cosine squared theta. And then we have plus sine squared theta. And that's all over cosine squared theta. Equals 1. And that's all over cosine squared theta. So when we do that, cosine squared theta divided by cosine squared theta is just going to give us 1. And then sine squared theta plus cosine squared theta, or divided by cosine squared theta, that's going to be tangent squared theta. And then 1 over cosine squared theta is going to give us secant squared theta. So writing this a little more cleanly, our second trig Pythagorean identity is going to be 1 plus tangent squared equals secant squared. So 1 plus tangent squared theta equals secant squared theta. And there is our second identity. Our third Pythagorean trig identity we're going to derive is, you probably guessed it, instead of dividing both sides by cosine squared theta, we're going to divide both sides by sine squared theta. And so when we do that, we're going to get cosine squared theta over sine squared theta plus sine squared theta all over sine squared theta. And that's going to equal 1 over sine squared theta. So cosine squared theta over sine squared theta, that's just the reverse of like sine squared over cosine squared. It's going to be cotangent squared theta. And then plus sine squared over sine squared of sine squared theta over sine squared theta. That's going to be equal to 1. And then that equals 1 over sine squared theta. And that's going to be cosecant squared theta. So that, my friends, is the 3 trigonometric Pythagorean identities. Well, this has been with Math Moments. I hope this video has helped you in understanding how to derive the trigonometric Pythagorean identities, where they come from, in terms of like using the unit circle and just using some little algebraic manipulations, little tricks to derive these 3 equations. And these are very helpful identities to use when simplifying trigonometric expressions, or even solving trigonometric equations. And also they're very useful for calculus as well when evaluating integrals or just simplifying any kind of expression or an equation. So I hope this video was helpful. Please feel free to like, comment, subscribe on the channel. And I look forward to sharing more videos with you on math. Have a great day. Take care.